previously? Sam, could you start first, please?
Me?
Hey, everybody, put your finger on as, page 369.
As you learned previously, the coordinates of an intersection point of two graphs can be exact or approximate depending on whether the intersection point is located on the intersection of two grade lines. You also learned that you had to use algebra to prove an exact intersection point.
Thank you. Wyatt, notice.
Notice the units of measure of the independent and dependent quantities in IG and CG are the same.
In both functions, I times g and c times g, the g represents the independent quality, gearboxes, and the dependent quantity is dollar. However, the dollars in each function represent different types of dollars. Why?
Why? Different types of dollars. Why? Why are they different types of dollars? One's dollars out of my pocket, and one's dollars into my pocket. Okay, what else is on that graph? Gearbox, that's all we know. Oh, wait. Is this dollars?
No way.
That's not dollars. That's
gearboxes.
number of gearboxes. Okay, so number of gearboxes. Interesting. All right. When determining the break-even point, Andy, go ahead.
Determining the break-even point, I break in between two functions more efficient transfer each function in equation. In this case, we're transforming the functions into the equation form to establish the unit of measure for dependent quantities.
Go ahead, Andy.
Dollars.
Okay, so we'll do a quick version here. I turned you back on. Good. Everybody put your finger down on the first line inside that little notebook thing. There's our functions, I of g, c of g. Go down to the middle line. What have they done? They changed the g to an x. So what'd they do right here, Christian? Change the g to an x. And now go down one more line. What did they do? Change the I and the C to Y. Okay, so this is set up to match our scenario, and then they changed the G to an X and the function notation to a Y. Flip the page. I don't like 4. When two or more equations define a relationship between quantities, Brody, they form a system of linear equations. What is the relationship between two equations in this problem? Blah, 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 blah. I don't like this. Substitution method. Great. I don't know about that. Number 6. Analyze the solution. Okay, so they solved this. Oh, take a look at this. Notebook, bottom of page 370. There's our two transformed functions. What do they do to the two transformed functions? Take a look at the two functions. What's different right here? What have they done? Eyeballs on my fingers. What do you notice? How did they make this middle piece here? How did they get from here to here?
Put them together.
They kind of put them together, but they put them together in a special way. Molly?
The y, or they put 8.5 as the y.
They substituted, and they set them, not loose, we wish, huh? No, they set them equal to each other. Why did they set them equal to each other? Because this one equals y.
Great. school system.
No worries. Well, it's being videoed. Yeah,
I'll look up
it's not on yet because we're still doing it.
Aha, there's the problem.
Yes. And they can just catch up whenever. They're doing fine, so. Okay? Bye.
Just stop distracting.
Alright.
They're gonna call.
They were trying to decide whether to tune in right now because they had a special something going on.
A special something.
Oh, what did you notice? What did I just do with the colors?
You highlighted the Y and then also the X's.
Okay, so if this one is Y and this one is Y, I can set them both equal to each other. We can also know this was the break-even point, right? This one is income. This one is cost. And at the break-even, the two are equal to each other. All right, so they set these equal to each other and simplify, 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 found an X. How does their X match what we found for our intersect? It's the same. Hey, Guillermo, put your screen down there. Okay. Oh, now that's too small. Here we go. All right, we can do this. What does the point in terms of represent in the problem situation? What does the X mean in our graph? Look back at our graph. What's on the x-axis? Not dollars. Gearboxes. X equals gearboxes. So at the break even, we have sold how many? How many gearboxes did they sell at the break even? Guillermo, are you writing this down? 16. In mathematics, it's 16.48, but do you think you can sell a part of a gearbox? Sold 16 or more. They really have to sell 17, huh? Because I bet you, well, mathematically, we can find how that intersects right here. If you're selling something, you probably are selling whole gearboxes.
Half the round up.
Yeah. Okay, solve for y. Describe the solution in terms of this problem situation. Okay, so at when, we've already done this, x equals 16.48, what was our intersection point? What did y equal? Did anybody write it down? Here. It's on my calculadora. It's probably on yours. When x is 16.48, what's the y? Then y equals 140.11. Okay, so x is gearboxes. What's on the y-axis, guys? Dollars. Okay, now, for my fundraiser, we were talking about $40. I bought $40 worth of stuff. I need to sell $40. These guys, it's $140. They bought $140 worth of parts. They need to sell $140 worth of gearboxes. What is the profit from gearboxes at the break even? If I bought $40 worth of stuff and sell $40 worth of stuff, what's my profit? 0. At the break even, at least you didn't lose money, but you're not making any profit either. You just traded hands in whose pocket that money is in. 0. At the break even point, no profit. Exact match there. Why does this break even point make sense in terms of the problems, or does this, don't worry about that. Analyze your graph of cost and income for the different number of gearbox. I like this. Can you stop that, please? Draw a box around the portion of the graph that represents when RR is losing money. Okay, back to our graph. This will be the last thing, folks. Here's break-even point. Put a star there or an arrow or something. Break-even point. Where on the graph are we making a profit?
16 or 17 actually.
Okay, well the break-even point kind of divides the graph into two halves. Are we making a profit over here to the left? Or are we making a profit over here to the right? Everybody put a little bit of a box right here. This is profit. Everybody put a little bit of a box right here. This is lose money. Wait a minute. Why is that? Oscar, why is this profit? It's the money made, but how do we know that from looking at these two lines?
They kind of drift off more.
They drift off more, but what's it? It's past the break even, and what do you need to be the higher amount to make a profit?
The income.
Income is higher than the cost. If you look backwards right here, here's the cost, here's the income. Who's higher?
The cost.
Right here, the cost is higher. That would happen if I bought $40 worth of snacks and I only sold $20. I'm losing money. I didn't even get my money back, okay? Right here, income, more money than cost. That's going to be a profit. Ooh, that's way more than what our brains can handle right now. You can hold your calculators. I need rulers. Where did I put that box? Rulers and books put away, please. Rulers and books. I'll put the rulers kind of over here. Pull out your homework packet. Where's mine? Find your homework packet, please. The cucumber. Sit down. Walk away from the yardstick. Homework packets. Good job, Christian. Good job, Molly and Myra.
Good job, Andy.
Come on, Guillermo. You got it. Good job, Brian. Good job, Kenya. Good job, Chris B.
Good job, Andy.
Good job, Andy. Nice. Good job, Christopher.
I gotta go too.
Okay, the last time we looked at this together, we looked at this page. Okay, because Molly asked a question. What else would be good to look at together? How about the back page? How are people doing on these? Have you got that far?
No.
Does anybody have a set specific question?
What do you do with the
I love that question. Here we go. Looking at the back page. Division ones. One thing that's a little hard about this worksheet is the way they show the division. Shh. If you can hear me, snap once. This is x over 3 equals 4. How do I get rid of that 3? Multiplication. Times by 3 here, times by 3 there. That'll cross those out. X equals 12. So here's another one. Shh. X over negative 6 equals negative 6. What did we just do? How did we get rid of the bottom of the fraction before? Times by whatever's underneath the x, negative 6 times by negative 6. Those two cancel out, and these two we need to multiply. 6 times 6 is 36, and negative times a negative is?
A positive.
So x equals 36 positive. You guys, do number 5. Can you look through your stuff? Oh, so you have the packet, but you're missing the last page? Okay, you guys are doing number 10, yes? Oh, sorry, it's not. It's number 5, but believe the answer. Christopher, what do you have for 5? Okay, do it now, please. X over 5 equals 2. What do we have to do right here? Could you guys put your screens down, please?
Put x over 5.
Martine, screen down, please. We got the x over 5. Now what do we do? Times 5 times 5. X equals 10. Take a look down here, number 11. What's the first thing we have to do?
Distribute.
That means multiply, but we got to be careful to multiply 2 places. Negative 7 times 10 and negative 7 times negative 3. Oh, it's not negative. What happens when you times a negative, it becomes positive 21x. So distribute is 2 multiplies everything that's inside multiplied by the negative 7. Now we want to get x by itself. How do we get rid of this negative 70 over here? Well, we're going to add because it's negative. 21x equals, what's happened? 0. Divide by 21. X equals 0. Is 0 an okay answer? Yeah. Okay. Let's take a look at 10. We can choose what to move first. We have x's and numbers on both sides, but we have to move all the x's to one side and all the numbers to the other. Myra, what would you choose for a first step? There's not a wrong answer. She's going to subtract 5, and we're also going to subtract 5 from the other side of the equal sign. 4x equals 33 plus x. Now, there is one thing we want to do. There is a specific next step. We want to get x's on one side, numbers on the other. So, how do we get this x over with the other x's?
Wait, no, subtract.
Subtract. It's being added to something. To undo addition, you subtract. It has an invisible 1 in front of it. So what's 4 minus 1?
3.
So I'm going to have to bring that over here. 3x equals 33. So everything canceled except for 33 on the right. And we have 4 subtract 1. Oh, all right. How'd you get that?
By
Divide. Okay. What one do you want to do next? Pick one more off this page. Oscar, your pick.
14.
No, 8.
do we have to do 16? And 15?
16.
If there's nowhere to put like.
Oh, we can do it. There we go.
Right.
16 minus 2. First step is distribute. What does that mean, Guillermo?
You use the function
How do you do that?
with your
Pen
pen.
doing this and what else? Distribute means I gotta multiply times the 5x and multiply also. Come on. You,
10.
Guillermo.
10.
Do you agree with them?
Yeah, I agree with you.
Okay. Guillermo, what's negative 2 times 5?
Negative 10.
Thank you. What's negative 2 times 10?
Negative 20.
All right, I want x's on one side, numbers on the other. Can you? Oh. There we go. Kenya, what should we do next?
You can plus 20.
Plus 20, plus 20. Negative 10x equals 30.
Then you have negative 10 on both sides.
Divide by negative 10, divide by negative 10. X equals negative 3. Where to put that? Right here. All right. Oh, it's about that time, my friends. Where's the calculator box? Is it by Andy? Calculator box over by Andy.